Next part is functional group, but before we go to the functional group, I want to tell you something. Functional group is something which add the extra qualities in your molecule. Let's take an example. Let's say if I have a chain like CH3, CH2, CH2 and the functional group, then this functional group is going to give a very distinctive property to this compound and will add up a lot of new properties, and those properties will specific to the functional group. So basically the presence of that functional group in a carbon chain will make it quite different, will add new properties, will add the changes in the physical appearance as well as in the chemical reactions. So this is very important part of a compound if an organic compound carries it. Hydrocarbon is something which has only carbon and hydrogen. An organic compound is something which has carbon, hydrogen, and maybe the other functional groups present in it. Functional groups are made up of carbon, oxygen, hydrogen. It can have chlorine, bromine, phosphorus, sulfur, nitrogen. Can have any other element in it. Okay, so what are functional groups? These are part of the molecule which are highly reactive. So this is very highly reactive part. When it comes to show the reaction, this part will show the lesser or slower reaction as compared to the functional group. These will take part in the chemical reactions and will also decide the physical and the chemical properties of an organic molecule. If the functional group is present, then the carbon chain present over here is called as residue group. Okay, so the name of the carbon chain is called as residue group or alkyl group, or I told you substituent chain, and so on. There are multiple such names, and functional group is the one which is the important part and which will help you in identifying how to name the compound, what will be the properties of the compound, how will be the physical appearance of the compound, as well as physical properties of the compound. So here now the carbon chain is not as important as the group which is present on it. Let's talk about the different type of functional groups. But before I explain you all the type of functional groups, we will be talking about the few ones which have the common names or the trivial names which are widely being used for the competitive exam questions. We will try to understand their common names and their common names or trivial names so that we are aware of their common names. IUPAC name, all of us will know after some time. We will know how to derive the name. But if a common name is being asked, it is important for us to interpret and understand what compound it is. So right now we are going to deal with the common names and trivial names of some functional groups, not all. We will be coming to other functional groups soon. So which all functional groups we are talking about? We are going to talk about the aldehyde. We are going to talk about aldehyde. What is aldehyde group? Aldehyde is CHO group. Let me just write it on a plain slide, by the way, so that you will be able to understand and you will be able to see. So aldehyde group is C double bond OH group. How it will be connected to the chain? Basically, you have CH3, CH2, 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 and so on. You can have any length longer carbon chain and a group present over here like this. So this is the group which is an aldehyde group. Aldehyde group has a carbon with double bonded oxygen and a hydrogen. Another group which we are going to talk about is a carboxylic acid group. This is the carboxylic acid group. Again, it will be attached to any kind of chain. Let's say my chain is two-membered carbon chain, and then this is the functional group which is attached on it. Third compound which we are going to talk about is the acid halide or acid chloride group. Acid chloride group. What is the acid chloride group? If you look at it, this is a carboxylic acid group. Carboxylic acid. This group is acid. Okay. Now from this carboxylic acid group, if I remove OH and I add Cl over here, the name will change from carboxylic acid to acid chloride. What I have done, I have just removed OH and have put Cl over here. So this is my acid chloride group. Again, the chain will look like this if any acid chloride is present in any compound. So it will be COCl. This is how the chain will look like. Next is amide group. What is amide group? Amide group is again some change in the carboxylic acid group. So carboxylic acid group was COOH. You remove OH and add NH2. So CONH2. This is the amide group. How will it look like with the chain? So you have CH3, CH2, CH2, C double bond O, NH2. I've just taken the random chains. Okay. So this is how the amide group will be attached to the carbon chain. Mind it, if I have to write the generic formula of Aldehyde, I will be writing RCHO. What do we mean by R? R means any length longer carbon chain, and CHO is the group, functional group which we are talking about. If I have to write a general formula for carboxylic acid, I'll be writing it as RCOOH. Again, R means any length longer carbon chain and COH is the functional group. If I have to write the general formula for acid chloride compounds, I will write it as RCOCl, where R is again any length longer carbon chain and COCl is the group. And if I have to write a general formula for amide group, I will write RCONH2. R represents here any length longer carbon chain. Again, I'm repeating this. R represents here any length longer carbon chain, any type of chain, doubly bonded, singly bonded, can be cyclic, can be anything. R means anything, any carbon chain. Okay, so these are the groups which we are going to talk about. Basically, we are going to talk about their common names, which are very widely used, very commonly used, and we should know these common names to identify the compounds when we get them in the question. So now let's understand few things. I will show you the table over there, but it is a little clumsy. A lot of things have been written over there, so I will not be able to explain. So I'm using the plain slide. So let's say I have taken aldehyde. Aldehyde is a CHO group. Now when I'll write a common name for aldehyde, common name, there is a suffix which we are going to use in the common name to represent aldehyde group presence over there, and that suffix is nothing else but the aldehyde itself. This is the suffix. Please understand this very carefully. Similarly, let's talk about carboxylic acid. Carboxylic acid is COOH group, and in the common name also, the suffix what I'm going to use to represent the presence of COOH over there is oic acid. Let's talk about these two compounds first, and then I'll come to acid chloride and amide. So now we will understand the common names of word root. Word root starting from 1 till 5. So I have n is equal to 1, 2, 3, 4 and 5. Only till 5, n, basically the word root, n means nothing else but the number of carbons present in the carbon chain. Okay, so when I'm talking about the number of carbons are going to be 1, 2, 3, 4 and 5. These will, whenever we name, I told you we use the word root as the main base to identify how many carbons are present in the chain. So as I mentioned, n is equal to 1. That means my carbon chain of, no matter you talk about aldehyde or you talk about the carboxylic acid, will carry only one carbon. So what all possibilities are there? Let's see. This is my aldehyde. It already has one carbon. So I cannot place another carbon over here, and I need only one carbon in the first case. Okay, so here I will fulfill its valency with the hydrogen only. Similarly, in the case of COOH, there is one valency left and I need only one carbon in my chain, which is already there in the functional group. So what I'll fill its valency with? Only hydrogen. Let's talk about the second chain. So here, if I have to add, let's say, 2 carbons over here, so I will write COH, and then the another will be carbon over here. Another carbon's valencies I'll fulfill by hydrogen, so it will be CH3 CHO. Similar way here, it will be CH3 COOH. Now I want to make aldehyde of 3 carbons. It will be C, C and CHO. So I'll write it as H2 and H3. And here again, I'll write it as CH3, CH2 and COOH. Similarly, here I'll write CH3, CH2, CH2, CHO, CH3, CH2, CH2, COOH. My bad, very bad handwriting I have. CH3, CH2, 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 CHO, and again over here CH3, CH2, CH2, CH2. My bad. COOH. So these are the chains when you have N is 1, N is 2, N is 3, N is 4, and N is 5. N represents nothing else but the number of carbons present in the compound. Okay. Now, depending upon the N over here, we have some common names. For N is equal to 1, let me just write it over here. I'll just write it somewhere over here. Okay. So N is equal to 1 has a common name, and that is common name is form. That's not the actual IUPAC name. IUPAC name, we already know what is it. It is meth. It is common name, and common name is form. For N is equal to 2, the common name is acid. For N is equal to 3, the common name is propion. For N is equal to 4, the common name is butyryl. And for N is equal to 5, the common name is valar. These are the common names being used for the word root starting from 1 to 5. So what we are going to do to give the common names to these aldehydes and carboxylic acid, I've already told you what is the suffix for aldehyde and carboxylic acid word root. Now we know. So we will just add word root plus suffix. That's all. So here suffix is aldehyde, common name of N or the number of carbons or the word root. We already know for the first carbon or the only one carbon we have formed. So the name of the compound will be formaldehyde. Here it will be formic acid. Similarly, you must have heard of these names. You must have seen it somewhere. Similarly, now in the second case, the common name is acid. Sorry, the common name for the word root is acid, acid and aldehyde. So that's how becomes my common name. Here it will be acetic acid. It's only ic acid. It's not oic acid. Oic acid is used in the IUPAC naming, that is standard naming. Here it is only ic acid, not oic acid. So this third thing is propion. So propionaldehyde, that will be the name. And this will be propionic acid. Similarly here, in the case of fourth, it will be butyryl aldehyde. And this will be butyric. So L we will remove. So because it's a common name, many alterations are possible. So the name is, I think I have written really poor way. So butyric acid. For the fifth one, valeraldehyde. And here we will be using valeric acid. So these are the names, these are the common names which can also be understood through some rules like this. So we have understood N, how these N's or how the number of carbons can be given some common name or how the word root can be given the common name, and what is the common suffix for aldehyde and carboxylic acid, and we could derive the name of the respective aldehydes and carboxylic acid. Let's just quickly have a look on the table and just verify whether the names are right or not. So this is my table. In the first case, I have written form for the number of carbons 1. First compound we are going to deal with is the aldehyde, and the second is carboxylic acid. I have written oic acid over here. Again, please make the change. It is just ic acid. Ic acid. Okay. These are the suffixes mentioned over here, which will be used after the word root. Okay, word roots have been mentioned over here. So one is called as form, so it is formaldehyde. This is what exactly we had spoken about. This is formic acid, this is acetaldehyde, this is acetic acid, this is propionaldehyde, and this is propionic acid. And similarly, let's quickly go to the next page table, that is butyr. 4 is butyr. So it is butyraldehyde. Okay, I had made a mistake over here. I had written butyryl. So it's not butyryl, it's butyr only. Okay, so that was my mistake. You can correct it. And this is butyric acid over here. So it is 5 is valer. So it will be valeraldehyde. And again here valeric acid. So till here we have done correct. So we have learned a part of the table. Let's talk about the acid chloride and amide till here. Now let's talk about acid chlorides. Acid chlorides and amide. Okay, so now when N is equal to 1, acid chloride COCl, it already has, similarly amide CONH2 already has both of these already have one carbon, so we do not require any other carbon chain to be present over here. So we will just fulfill the valency by hydrogen. So this is N is equal to 1 structure. N is equal to 2 will be CH3 COCl. I hope you are understanding why I have written CH3 COCl. First I'll attach it with the carbon, and then remaining valencies I'll fulfill with hydrogen. So it will be CH3CONH2, then N is equal to 3, which will be CH3 CH2 COCl, and then CH3 CH2 CONH2. N is equal to 4. I don't want to write a lot, so I'll be just writing CH2 whole thrice, not thrice, sorry, twice. COCl. Why I've written twice? That means CH2 unit is repeating twice. Okay. Then CH3, CH2 whole twice, CONH2. This is nothing else but CH3, CH2, CH2 twice. So I've just written the whole twice to just show that repetitive times twice it is getting repeated. That's how you can also write and save some time. N is equal to 5, CH3, CH2 whole thrice, COCl. CH3, CH2 whole thrice, CONH2. These are the compounds till N is equal to 5 for acid chloride and amide. Now, acid chloride's suffix we'll talk about. It will be aryl chloride. And for amide, it will be simply amide. Okay, so aryl chloride is the suffix for acid chloride, amide will be the suffix for amides. We already know the name for N is equal to 1 is form, so it will be formyl chloride, and this will be formamide. Very simple. Now this, in this case it is acid, so it will be acetyl chloride. N is equal to is acid. Okay, so acetyl chloride, and it will be acetamide. This will be the name. Next, come to the third one. Third one, I have told you it is propion. Just give me a moment. It is propion. So it will become propionyl chloride. And this will become propionyl, no, not nyl, sorry, propionamide. This is butyr. I had written butyryl earlier. Please change that. It's my mistake. Now this will be butyryl chloride, and this will be butyramide. This is Valar, so it will be valaryl chloride, and this will be valaramide. That's how the names for the compounds from N is equal to 1 to N is equal to 5. These are the common names of acid chlorides and amides. These common names you should be able to interpret, and that is why I have explained to you with the smallest or the easiest rule possible. The common names do not follow any rules, but we have tried to find out few and then we have implemented them over here. So N from 1 to 5 we have understood. There are some terms, again there are some different type of combinations of carbon which also have the common names and can be used in aldehydes, carboxylic acids, acid chlorides and amides. So let's see those combinations as well. But before we see that, let's quickly verify what we had learned. So this is acid chloride group COCl. It has a suffix aryl chloride, and amide has the suffix amide. The first compound is formyl chloride, then formamide, then acetyl chloride, then acetamide, then propenyl chloride and propanamide. And then come to the next slide. So N-butyryl chloride and N-butyryl amide, N-varyl chloride and N-valar amide. N means nothing else but the normal straight chain. If it would have some branch, then we would have named it differently. N just represents the normal straight chain. Even if you won't write N, it won't matter much. Okay. Next, as I mentioned, that we have to talk about some other common names also, where some carbon combinations are there which have been called using the common names, and we can use those common names in case of aldehydes, carboxylic acid, acid chlorides and amides also. So we have one combination, that is 3C plus 1 double bond. What do we mean by 3C plus 1 double bond? That means total number of carbons in the chain will be 3 and it will carry one double bond. This is what the 3C plus 1 double bond means. Any such combination will have a common name, that is acryl. So if I'm talking about the aldehydes, CHO, one carbon is already there, and then total number of carbons what we require are 3, and we require one double bond also. So this carbons, so look at the aldehyde thing first. So aldehydes 4 valencies are already complete by bonding with this carbon, right? And now we have formed a single bond between these two, and we require what? We require a double bond. So double bond cannot be formed over here. Double bond cannot be formed over here, because in that case the valency of this carbon will become 5, which is not possible. So that's wrong. And the only place where we are left with to put a double bond is this. Okay, so now fulfill the valencies. This will be CH2 and this will be CH. So the compound will look like as CH2 double bond CH single bond CHO. That means total number of carbons are 3 with 1 double bond present in it, that kind of aldehyde. But any such combination, C double bond, C single bond, C kind of combination, has a common name, and that is acryl. When the aldehyde will be formed, using this structure, we will call it as acryl aldehyde. Look at it, acryl aldehyde. Understand this. This is important. Similarly, if I have to form the carboxylic acid of such kind, I will put C double bond C single bond COOH, will fulfill the valencies. So it will be CH2 double bond CH single bond COOH, and now this will be acrylic acid. Look at it, acrylic acid. Similarly, I can make a small change over here when I have to make an acyl chloride, and then this will become COCl, and then the chain will be this, and it will be called as acryl chloride. Similarly, I can make an amide of it. I can just remove the NH, this thing from here, and put an NH2. Okay, and this will be called as acrylamide. Next combination we are going to deal with is total number of carbons in the chain will be 4. So 1, 2, 3 and 4, and there must be a double bond, but there is a mandatory condition for the double bond to be present on the second carbon. So this is first carbon, this is second carbon, so double bond should be here. This kind of chain will have a specific name, and that will be called as croton. Now, out of these 4 carbons, 1 carbon can be an aldehyde and remaining chain will be like this. Or the 1 carbon can be a carboxylic acid, or the 1 carbon can be acid chloride, and then the 1 carbon can be an amide group. And then we will have names accordingly. See, rest of the positions where I have not written hydrogen, you can fill the hydrogen according to the valencies. It's as simple as that. So here, what will be the name of these compounds? As I mentioned, the common name is croton, so it will have croton aldehyde. Look at it. So it is croton aldehyde, absolutely correct. This will be crotonic acid. This will be crotonyl chloride. And this will be croton amide. So I don't think there is a lot of rocket science involved in it. Just you need to remember few things, and those are common names of word root. That is important. At least this much you can remember, and then you can use the logic and make the name. Okay, so this is about some of the compounds having common names and the names which are being used here and there in many of the papers like NEET paper, JEE mains paper, KVPY paper, advanced papers. You may find the questions with these names and you should be able to identify them. Okay, so next let's talk about the another type of common names for other type of groups. What are 3 groups we are going to deal with? One, we are going to deal with CN, which is called as nitrile group in general. Okay, and we can also the suffix what we use for it is, for the common name is O nitrile. Another group which we are going to deal with is NC, which is just reverse of CN, having one coordinate bond from nitrogen to carbon. Okay, and it has a common name, which is common suffix name, and that is O isonitrile. Okay, And then comes the ester, COOR. R means any length longer carbon chain over here. So we have ester, and the suffix what we are going to use to represent this ester group looks like this: C double bond O O R. This is my ester group. Okay, so this R can be any length longer carbon chain, and the suffix what we are going to use to represent the ester group is 8. That's it, 8. Okay, now we already know what is the word root for n is equal to 1 to n is equal to 5. That is, one is called as form, second is called as acid, third is called as propion, fourth is called as butyr, fifth is called as velar. Then the combination of 3 carbons with 1 double bond is called acryl, and the combination of 4 carbon chains in total with the double bond present in the center is called as croton. And now we will use these common names of word root along with these functional group suffixes, and we'll see what names we will get. Okay, so if I have CN present over here, the first compound what can be formed is HCN, and the compound will be called as formonitrile. Why formonitrile? Formed due to the presence of only one carbon. O nitrile is the suffix anyways. Next comes to the compound of NC, that is HNC. We need only one carbon, so that's how it will be written. One carbon is already present in the functional group, so we will fulfill the valency using the hydrogen. It will be called as formoisonitrile. Now here, so when we are talking about ester we will deal little separately. I'll explain you in detail how the ester naming should be done. So I'm just avoiding ester right now. We'll talk about ester separately. Right now we'll just talk about CN group and NC group. Okay, so these two groups we will talk about. But before, I'll just explain you about CN and NC. There are a few more things which I want to tell you about O-isonitrile group, that is NC. So before I explain you all the names of nitrile group and isonitrile group, I want to talk a little more about isonitrile group. This NC is called as isonitrile group, where one is the one bond between nitrogen and carbon is the coordinate bond, and you can say it is a dative bond. So you call it coordinate or dative bond, both are the same thing. The group actual name is isonitrile, and the suffix what we are going to use is O-isonitrile. Okay, so here there are few other things. There can be other suffixes also. Let me just tell you. So this is suffix 2 which we can use, and that is isocyanide. Isocyanide is also a kind of suffix which I can use, and there can be a third type of suffix, that is carbolamine. So 3 suffixes possible for isonitrile group. Generally you will find isonitrile or isonitrile being used for the common name, but you may find isocyanide and carbolamine also. Now what you have to be careful about when we are using O-isonitrile or isocyanide or carbolamine, let me just show you. Let's say if I take an example of HNC, then the name will be form O-isonitrile. Nothing complicated over here. Now complexity will come when we'll have more carbons. Let's say if I have CH3N triple bond C, the name can be acetoisonitrile. This is one name. Usual process, n is equal to 2. N is equal to 2 has a common term, that is acid, and O-isonitrile is the term which we are using for NC. Now it can have the other name also. Let me show you what other names it can have using the suffix 2 and suffix 3. So if I'm using suffix 2, the name will be form isocyanide. And similarly, if I'm using the third suffix, name will be form carbolamine. What does it prove? That I'm counting one carbon lesser. It was 2 carbons present in the chain, so the word root's common name should be acid, and I'm not using acid, I'm using form. Why? Because there is a rule for suffix 2 and suffix 3, that is NC's carbon will not be counted while naming the word root. So here total carbons are 2, but I'm not going to count this carbon. I'm just going to count this carbon to find out my word root. So word root here I can use is form, because I cannot consider the carbon of NC. and I will just write form isocyanide, and isocyanide itself will mean that I am talking about NC. I'm not counting the carbon of NC. I'm just counting an additional carbon to it attached in the chain. Similarly, form carbolamine will mention that carbolamine means NC and form means one more carbon attached to it. Okay. Whereas in case of isonitrile, we are counting the total number of carbons. So basically, C should be 2 in total, one of NC and one of this. That's how the names are. Okay. So we are using isonitrile right now to avoid the confusion, but you may find this and you have to remember this rule. I have written it on the table also so that you don't forget, but I'm not very sure whether you'll be able to understand the table properly or not. So that's the reason why I have explained you separately. So I have written it over here. If suffix isocyanide is used, then C of NC is not counted, and same for the carbolamine. So I hope now you'll be able to figure out what we are talking about. So now let's very quickly see the names of the compounds. HCN will be called as formonitrile, HNC will be called as formoisonitrile. Come to the next slide. CH3CN will be called as acetonitrile, CH3NC will be called as acetoisonitrile, then propion nitrile, then propion isonitrile, then N-butyronitrile, then N-butyroisonitrile, N-valeronitrile, and N-valeroisonitrile, acrylonitrile, acryloisonitrile. This is 3C plus 1. Just look at the structure now. 3C plus N, where 1, 2, and 3 carbons are there. Here also 1, 2, and 3 carbons are there. So next is croton, where you have 4 carbons with 1 double bond on the second carbon. So double bond is on the second carbon and the groups are attached. So this is crotononitrile and this is crotonoisonitrile. So naming of NC and CN both are done. Next, what we are left with is the ester naming and some other common names, which I'll cover in the next class because it will become too much for you to understand right now. So in next class, we'll be talking about the ester naming, we'll be talking about some other common names, and then next, what is required to understand the carbon chain properly to name it through the standard naming, that is IUPAC naming.